Hello, my name is Megan Sawyer, and I will be speaking today about the use of technology in planning and sustaining cemetery forests for future generations. Life Force believes that as steward of Conservation Cemetery, it is important to use technology to protect the legacy of our loved ones and the environment. This presentation will briefly introduce the concept of GIS mapping and will present a case study of a hypothetical property in Henniker, New Hampshire, on how GIS mapping can help a conservation plan for its future. Preserving the legacy of the land is important when considering the future of a conservation cemetery. The mission of the Conservation Cemetery is to preserve the surrounding land while providing a place for future generations to visit their loved ones. This next series of slides will provide a brief overview of Geographic Information Systems, or GIS mapping. Geographical Information System mapping is based on the science of geography and integrates many types of data in the formulation of a cohesive visual aid for understanding a problem or a question. Depending on the depth or direction of the analysis, GIS mapping can help researchers identify trends and interpret causal relationships. Researchers can also use GIS mapping techniques to present a visual to audiences who may not be familiar with the nitty-gritty data to help them understand the results of the analysis. As a conservation cemetery, Life Forest used GIS mapping to aid in the planning of memorial trees and groves by analyzing, in conjunction with local arborists, the best trees for the soil and land type. As GIS mapping incorporates spatial coordinate information, or more broadly speaking, GPS coordinates and data at those coordinates, a conservation cemetery can use this technique to walk their land and plan future directions of the cemetery, including walking paths, memorial gardens where burials are not viable, and places for reflection. These can tie into local and regional databases of trails and paths if the cemetery so desires. When a conservation cemetery is planning for an expansion on a current property or is looking at a new parcel of land entirely, it can be helpful to get a lay of the land, so to speak. Data that can be helpful in this process includes political boundaries such as townships, which can demonstrate if the land in question straddles more than one township or county, and road type, including the class of road. This latter point, especially in New England mud season, can determine if the road is maintained by the town or the state and may give an idea of access in various seasons. Other information that may be helpful in this preliminary period, even after the parcel is obtained, is watershed and wetlands information, soil information including soil type, farmland type, which gives an idea of the health of the soil, and topographical information including slope and major elevation changes. Many states have repositories for the previous mentioned data. For example, New Hampshire houses a wide variety of data at granite.unh.edu. The data at this site spans information from fire stations and well sites to digital satellite images of the states. In addition, municipalities often provide some data for free as a downloadable file or through a GIS online viewer. For initial planning purposes, the online viewer is often sufficient to generate an idea of what the basic region looks like. For a more in-depth analysis, more digging is necessary, and often the town hall is the first place to start to determine if GIS files are available for free or purchased for private use. Once you have a GIS file, of which there are several types that are beyond the extent of this brief introduction, it is essential to have a viewer to open these files. Two such viewers are ArcGIS and QGIS. ArcGIS is probably more well-known than QGIS, and the online version allows you to view your GPS files. In fact, many municipalities use an ArcGIS viewer or a subsidiary of ArcGIS to demonstrate their GIS information online. QGIS, which is the program that will be demonstrated in this example in the next several slides, is an open source program parallel to ArcGIS that has additional features continually being added by the user community at large. The next series of slides will demonstrate the capabilities of the QGIS program to label soil type, slope, and wetland prevalence in an arbitrarily defined region in Henniker, New Hampshire. On this slide, we see the mapping program QGIS, which uses GIS data and geospatial data to create maps. Here we see a map of all the townships of New Hampshire. This is a starting point that most state data often has, either the entire state or region, with information about the town or different mappings. We see that we can add information about the roads, here indicated in red, or we can add information about the wetlands area, here indicated in pink. Notice that not all townships have been mapped with the National Wetlands Inventory Plus areas. We see up here, especially in the northern part of the state, that the NWI Plus data set has not reached this northern edge of the state. That does not mean there are no wetlands in this northern edge of the state. It just means that for this particular data set, the NWI Plus, this map has not been completed. So for the purposes of this example, we're looking at the town of Henniker, here indicated in red. And so if we zoom into this town, what we can do is we can look and say, well, if we're considering just the soil data, let's look at just soil data. We see that the town of Henniker has a lot of soil data here. The soil data is indicated with, let me turn on. Here the soil data is indicated by gradients here, where each little polygon indicates a different type of soil. So in the town of Henniker, here indicated in brown with soil data, I've turned on the labels for the slopes. But it's hard to tell what exactly is the soil data that we need when we're looking at this. We first need to define ourselves a region. We can also look at the wetlands data with Henniker, and so we can see how the wetlands inventory flows through the soil data, as well as the road mapping of Henniker as well. So we can see Henniker has some properties where we have soil data, wetlands, and road data. So taking out the soil data makes this more clear with just the wetlands and the road. Now, if we look at a potential portion of land here indicated in this green portion, so if this is Henniker at large, the small green polygon is an arbitrary parcel of land. And if we're interested in looking to see what is happening with this arbitrary parcel of land in terms of wetlands data and soil data, if we were a conservation cemetery, we can look into this land to see what's happening. So let's zoom to that layer, and we'll turn on our soil data. So let me turn off some of the Henniker soil data. So Henniker soil data, if we were to zoom out slightly, we see that we have these different areas of soil with different types, from Pillsbury fine sandy loam with 0 to 8% slopes with very stony, to scary fine sandy loam, Peru fine sandy loam, meadows edge peat, and then we have our region. And the data that we are truly interested in is just the data contained within the region of this polygon. So we'd like to clip our data to this polygon, and we can do so by just looking at these pieces here. So if we look at the soil here, we see that we can color the soil, these different regions, going back to the Henniker, we're clipping out regions of our soil. We can color the areas of these smaller regions according to their slope. Here, this orange strip is sloped less than 1%, the green strip is slopes between 2 and 4%, and the red is slopes greater than 4%. We can also apply a label to these data where we can add the soil type as a label, and we see that the soil type here is now given as Pillsbury sandy loam for this little section, Peru fine sandy loam, meadows edge peat, and more Peru fine sandy loam on the edge. This gives an idea, if you're a conservation cemetery, on how your land might look in order for planning purposes. You can also add in wetlands data. So we see the meadows edge peat falls in a national wetlands inventory area. So we see that there are several spots that would make inappropriate burial locations. GIS mapping and technology are helpful not only in determining if a parcel of land is appropriate for a conservation cemetery, but can also be used for incorporating information about in-use conservation cemeteries. This final section will discuss how Life Forest uses GIS mapping and GPS technology to connect the legacy of the land with the legacy of our loved ones. GIS mapping allows for the incorporation of spatial data into maps, which can richly enhance the user experience. By adding details to shapefiles that build a GIS map, these shapefiles can hold a wealth of information conservation cemeteries can use for planning purposes, as well as documenting burials. At Life Forest, we use GPS services GPS devices to determine the GPS coordinates for each memorial tree and record information such as the date of birth, death, and cremation number to the tree's location in the shapefile we use in our GPS map. Other pieces of information that we can record are the type, date of planting, and expected lifespan of the tree to better help our arborists plan for the future health of the conservation forest. Conservation cemeteries, after determining what appropriate parcels of lands may work for their cemetery, need to use technology in order to preserve the legacy of those buried amongst their groves. For this example, we have our arbitrary plot of land in Henniker, New Hampshire. We have 3 individuals, Robert Smith, Jane Doe, and Sandra Wood, here indicated. If I were to click on the point for Robert Smith, the GPS coordinate for point for Robert Smith is given XY coordinates. Robert Smith has a variety of information associated with that point. The name, the beneficiary, the obituary to link, date of birth and death, tree type, if it's a pre-need plot. If I were to click on Sandra Wood, we can see that Sandra Wood is a pre-need plot and thus doesn't have a date of death at this point. But you can still link like a beneficiary and other coordinates. For Jane Doe, you can see that there are a similar sort of, you don't have to fill in, there's no obituary link, but all this information is referenced in the system. And this allows you to do things such as, if you were to have a Children's Memorial Day, you could search for all plots where the age of the person who has died is above or below a certain age. Or if you were to have a Remembrance Day for somebody, you could go and help use their obituary, update their obituary as things or as beneficiaries changed. Life Forest believes that through appropriate stewardship of our forests and conservation land today, our memorial trees and groves will be around for generations to come. Thank you for your attention, and for any questions, please visit thelifeforest.com.